So this is the transient analysis of an RLC circuit. So in this circuit, we are having both an L and a C together. Let's solve it. So the question says the switch is already closed. The switch is already closed and steady state has been achieved. So this was closed and steady state has been achieved. So if this would have been remaining closed, then the capacitor would have charged with some current and the inductor also would have charged with some current. So both the capacitor and the inductor are charged up. At t is equal to 0, the switch is opened, which I have just now written here. T is equal to 0, the switch gets opened. Determine the current through the inductor. So part 1, first we will do is find out what is going to be the voltage source that we have to keep here and what is the voltage source we have to keep here. So that means we are interested in finding out, find V0 and I0. That means what will be the voltage source here and what will be the voltage source to be kept here. Why? Because both of these got charged. So we know what is the circuit diagram we have to draw. So before the switch was opened, when it was closed, 5 volt was passing through 2.5 ohms resistor, and then it was passing through the capacitor and achieved steady state. Now we know that steady state or final state, the capacitor acts as open circuit and the current passes through inductor. Now we know that at steady state or final state, the inductor acts like short circuit. Whatever is the voltage across this, that is going to be our V0 minus. Whatever is the current that is going to pass through this is going to be our I0 minus. So looking at the circuit, you can see that this is open. So there is not two currents I1 and I2. There is only one current. And that one current is flowing from 5 through 2.5 ohms through this short circuit and coming back at 5 volt negative. So that current we need to find out because that same current is flowing through I0 minus. So I can straight away say that I0 minus is going to be 5 divided by 2.5 ohms, which is going to be equal to 2 amperes. Now what is the voltage across this terminal? The voltage, as you can see here, since this branch is short, so the voltage across this will be 0. So that same voltage will appear here. Now some people may argue that, sir, in this side we are having 5 volt and some current is flowing, so basically some voltage should come here. No, the voltage that is here 5 volt and the 2 ampere current that is flowing here will generate an opposite voltage of 5 volts. So basically both of them will cancel off and still you will get a 0 volt here. So we can straight away say V0 minus is equal to 0 volt. So now the part 1 is over. We have found out what is the current and the voltage values. Next, let us see what is going to be part 2. For part 2, we need to redraw the circuit. So we want to find, what do we find? Current through inductor. Find current through inductor. Okay. So now we have to redraw the circuit. Now when this circuit is opened at t is equal to 0, then this voltage and this resistance both are not a part of the circuit. Now the only two components which are part of the circuit are a charged up capacitor and a charged up inductor. So let me draw that. So I am going to draw a capacitor and a charged up voltage source. Charged up voltage source plus minus V0 minus by S, but we know that V0 is already 0, so this is going to be 0. So actually there should not be any voltage source here but we have drawn because we are doing the problem one by one only we come to know. Next, inductor with a voltage source, but the with the direction of current, the polarity, it will be opposite. And here we know it is L I naught minus, which is, now what is the value of L? 0.5, isn't it? So 0.5 into I naught is 2, which will give us 1 volt. And this one is going to be 0.5 S, and this one is going to be 1 divided by S into 200 microfarad. And now we have to find out what is the current through the inductor. So we are interested to find out this current, let's say I dash, or let's say IA, or let's say IL, anything. So now I will write the KVL for getting a value of IL. So the current IL is going like this. So this is plus minus plus minus. Okay, there is the current IL of S I should write, because as you remember it should be Laplace. Okay, so we are straight away going to write the equation. So gives KVL gives us what? So 0 I am not going to write. So let's say back of the component. So plus 1 by S into 200 microfarads into I of S plus I of S 0.5 S, then minus 1 is equal to 0, from which you can see I of S I can take out commonly, and then this side I can write it as this 1 goes the other side, so it is 1 here, and here it is going to be 1 by 200 micro I can take up, so 10 raised to power 6 divided by 200 S plus 0.5 S. 200 will directly get cancelled with, not cancel, it will cut with 10 raised to power 6. So I will get I of S multiplied with the value of this one, if I am trying to find out, 10 raised to power 4 divided by 2, which is 5000 by S plus 0.5 S. I can write even 0.5 as 1 by 2. Let me write it as 1 by 2 because that will be much better to solve it. This is not anything special, it's just easy to solve. I am just going to write, instead of 0.5 S I will write it as S by 2, and then is equal to 1, or I will get IS is equal to S plus, so 1 divided by S plus 10 raised to power 4 divided by 2S, which I can, so S square plus 10 raised to power 4 divided by 2S, that 2S I will take on top, so I will get 2S here. And I can find out the current. So this is IL, so okay, I did not write it as IL, so IL, this one is also IL. Okay, so now I will get the current through the inductor IL of t by taking the Laplace inverse of 2s by s square plus 10 raised to power 4, and as you can see here, we can solve this directly because there is nothing much complicated here. It will come as 2 times s divided by s square plus 10 raised to power 4, Laplace inverse will be cos. So I will get cos, omega will be under root of 10 raised to power 4, 10 raised to power 4 under root is going to be 10 raised to power 2. So this is 10 raised to power 2, which is 100 t, u of t. So for u of t I will write for t greater than 0. So that's it. So we have solved the problem.